Then what happened to the kinetic energy of all molecules will increase. Then total energy of gas will increase. So therefore, what is int The energy of gas is nothing but int, or the sum of kinetic energy of all molecules is called as int energy. So therefore, the int energy is directly proportional to temperature. We are trying to derive one very best formula. So I think I need not to give every time explanation. If temperature increases, speed of all molecule increase, kinetic energy of all molecule increase, total energy of gas increases. The total kinetic energy of gas is nothing but called as internal energy of a gas. What is the symbol for that? The symbol is what we use, U. Therefore, U I'll put directly proportional to temperature. Okay, let's take another example. Second situation, what I do is like temperature is same, number of moles is same. Then I'll introduce another diatomic gas molecule. Okay, I will do one thing. Number of moles, let me increase. Temperature is same. Then 10 molecules were there. Each molecule was having 3 joules. Now what is the total energy? 30 joules. Then I'll bring 15 molecules now. Same temperature. Then how much it will become? 45 joules. So therefore, as number of moles will increase, int energy will increase. So therefore, the int energy depends also on number of moles. Same monatomic gas only, number of moles are increased, that maintaining temperature constant. So next again, third situation, monatomic gas, number of moles. Then I'll fill up with the same number of moles diatomic gas at same temperature. Tell me like which gas will have more energy? Yes, anybody? 10 moles of monatomic gas, 10 moles of diatomic gas. Both the gas are at same temperature. Which particular gas will have more energy? Anybody wants to answer? Diatomic gas, naturally. So therefore, the int energy of the gas depends also on what? It depends also on the degree of freedom. Getting the idea? It also depends on degree of freedom. So therefore, now I will derive and write straight away one equation, FR by 2. So therefore, for a given gas, int energy is directly proportional to temperature. This is the law you can better call. For a given gas, number of moles is constant. Degree of freedom, monatomic gas will remain monatomic gas only. So therefore, for a given gas, int energy is directly proportional to temperature. So how do you can write this one? Okay, I do have here. So like this, what happened? We have brought an expression for okay, able to understand this one. This is for int energy of a gas. Like this, we are writing this one, NFRT by 2. And this is something very, very important. We'll be discussing more numericals related to this int energy only. Anybody having doubt, you can just clarify yourself. If you have any doubt, you can just express your views, because I'll go to the next concept. Okay, all of you got the degree of freedom. Then from there is what I introduced the int energy of a gas, that one.
Sir, are internal energy and translational kinetic energy same, sir?
What we discussed till now. The total energy of a gas is called as an energy. In what form the gas will have energy? In the form of monatomic gas only translational, diatomic gas translational plus rotational. That's all.
Yes.
Hmm? Okay, I think all of you know ideal gas equation for n moles of gas, one molecule. Shall I write that equations or you know it from chemistry? For n grams,
We know it, sir.
you know it, this
Yes,
one?
sir.
Hmm? Per molecule, it will be PV equal to KT, we'll write it. For moles, we write PV equal to nRT. Okay, at least I'll write these two things, ideal gas equation. This is for n moles of gas. Hmm? PV equal to nKT. This is for n molecules of gas. I think these are the, for one mole, what we write PV equal to RT. For one molecule, what we write PV equal to KT. For grams of gas, I'll bring that R by capital M, gram molecular weight, I'll introduce like that. So these are the things we'll be using where all we needed. Okay, shall I go for, there's about next condition. So the intensity of gas is something very important. Say I'm repeating again, it's like a story, please do understand. What form the gas, monatomic gas will have energy? Kinetic energy, translational kinetic energy. So what is the intensity of monatomic gas? Translational kinetic energy. What form the diatomic gas molecule will have? Rotational as well as translational. So what is the intensity of diatomic gas molecule? Translational plus rotational kinetic energy. Finish all. This is finish all. You need to think very big here. Huh? So let me go for rate of collision idea. Now if I mix up this one, so the degree of freedom, so different types of gas will categorize here: monoatomic gas, diatomic gas, then triatomic gases. This is gases. What about degree of freedom? This will be 3, this will be 5, this will be non-linear, this will be 6. Okay, after this degree of freedom, it will be related to CV, so which is given by formula FR by 2. Molar specific heat molar specific heat of gas at constant volume. And from Mayer's equation, what we can write, Cp minus Cv equal to R. And what is Cp? Just like a formula you remember, this one, molar specific heat of a gas, Cp and Cv, will define it. Then we'll define quantity called as adiabatic exponent of a gas. So this gamma is defined as Cp by Cv. Okay, let's try to write all the formulas. Gamma equal to Cp by Cv, that one. So what is the Cv for monoatomic gas? 3R by 2, 5R by 2, 3R. What about Cp? 5R by 2, 7R by 2. So this will be 4R. What about gamma for monatomic gas? Cp by Cv, 5 by 3, 7 by 5, 4 by 3. like this for, so we can categorize the gases, and for gases, what is the degree of freedom, Cp, Cv, gamma. Gamma something very important, which is going to help us a lot. Of course, in KTG, just we'll try to remember. So now this, let me take one more equation. Cp, what we can write it as gamma Cv. So Cv, you can also write it as R by gamma minus 1. So therefore, what is the expression for integer? We designed it like this, no? So Cv is Fr by 2. So you can write NCVT. I'll suggest you don't use Cv because you'll get confused. Either use NFRT by 2, or you can also, in place of Cv, what you can write it as NR gamma minus 1 T. Okay, no need to think on it now. Just like a symbol you treat it. Later on in the thermodynamics, we'll go in depth Cv and Cp. Now this week, you need not to bother the Cp and Cv. Just leave it here. Okay, hereafter, integer means better to think this formula or this formula. Don't bother this. In books, they have given exclusive explanation using this, but try to avoid. Analyze using this or this one. Okay, now I'll mix up two gases. Means I have this is monoatomic gas, and we have mixture of gases. We'll take it. I'm going to mix up these two.